All right, problem 76, we have the function f that's continuous on the closed interval 0 to 5, and the graph of f prime, the derivative of f is shown here. So the question is, on which of the following intervals is f increasing? Okay, so the key is to recognize that the function f is increasing when f prime is positive, so when f prime is greater than 0. So all you have to look is on the intervals on where it's above the x-axis. So from 0 to 2, it's positive. And then after 4, so from 4 to 5, it's positive. And that's really all there is to it. You don't pay attention to how sharp it is or like if it's steep. Just look if it's positive. And then so the answer will be from 0 to 2 and 4 to 5. And so the answer will be D. '77, the height of an object at time t is greater than or equal to 1 is given by this equation where h of t equals t squared minus 16 over t plus 15. What's the velocity of the object at time t equals 3? Okay, so the height of this object is the same as basically the position of the object. So think of height as a position, just the vertical position. So velocity is the derivative of position. So velocity in this case will be the derivative of h. So h prime of t will be our velocity. So we want to essentially find h prime of 3. We want to evaluate that. Now, you could do it by hand or with a calculator. It doesn't really matter. I'll just do it by hand. So you taking the derivative. Remember, this is negative 16t to the negative 1. So then h prime of t will be 2t plus 16t to the negative 2 plus 0. So h prime of 3, we're going to basically plug 3 into t here. So you're going to have 2 times 3 plus 16 over 3 squared. So plus 16 over 9. So you're going to have 6 plus 16 over 9. 6 plus 16 divided. And you'll get 7.7 repeating. And so the answer will be B. All right, 78, the function g is differentiable and satisfies this equation where g of negative 1 equals 4 and g prime of negative 1 is 2. What's the approximation of g of negative 1.2 using a line tangent to the graph of g at x equals negative 1? Okay, so here we just have to really figure out the equation of the tangent line and then calculate what the value would be when x is negative 2 or negative 1.2. So remember, the tangent line or the derivative of a function tells you the slope at that point. So the slope of this tangent line, so again, it's a linear equation. So let's first start off with y equals mx plus b. So then the derivative or the slope of this equation will be 2. So we know so far that y equals 2x plus b. We want to solve for b, and we know that it goes through negative 1, 4. So if it goes through negative 1, 4, you're just solving this just like an algebra. Back in your algebra days, 4 equals 2 times negative 1 plus b, and you'll get that b is 6, and you'll get that your equation for the tangent line is y equals 2x plus 6. And so all you have to do now is plug in negative 1.2 for x, and that'll give you the approximate value at negative 1.2. I don't know why I overthought it. So g of negative 1.2. So plug in negative 1.2 for x. So y equals 2 times negative 1.2 plus 6. So negative 2.4 plus 6 will be 3.6. So g of negative 1.2 is about 3.6, which will be A. Right, Tara's heart rate during a workout is modeled by the differential function h, where h of t is measured in beats per minute and t is measured in minutes from the start of the workout. Which of the following expression gives Tara's average heart rate from t equals 30 to t equals 60? Well, this is actually really simple as long as you recognize or know how to interpret the integral, in this case, of her heart rate. So the total number of beats from 30 to 60 is simply just going to be, the integral from 30 to 60 of h of t dt. So if you want to find the average per minute, you just basically divide this by 30 or multiply this by 1 over 30. This is just the average value function equation. So then your answer would just be B. That's it. Right, 80. We're given that g be the function with first derivative equal to the square root of x cubed plus x for x is positive. If g of 2 equals -7, what is g of 5? So what we can do is be clever and set up an integral from 2 to 5 of g prime of x. Because when you integrate this, you're basically going to have g of 5 minus g of 2. This is what this is going to equal. Now, where we know what g of 2 is, g of 5 would then g of 5 minus g of 2, which is -7. So what we want to find is evaluate what this is in our calculator, what the integral of this function would be in our using technology. So let's set up an integral from 2 to 5. So that'll be 20.899-ish. So we have about 20.899-ish is equal to g of 5 plus 7. So g of 5, g of 5 would just be this minus 7. So we take away 7 from that, and that'll be g of 5. The g of 5 would then be about 13.899. So the answer is C. All right, so there you go. All right, for 81, it says if f as a function has a removable discontinuity at x equals 3, which of the following could be the graph of f? So this is really just knowing what a removable discontinuity looks like. And I think I like to think of it as like a hole. So I tell my students this is a hole. Like think of the graph being completely continuous, but then like you're gonna suck out like a hole. Like you're gonna have like an empty spot. So it would just be this one. So it's not this is like a jump. This is like a jump. This is an asymptote. So it would just be C. So think of it like you literally removed it and moved it down there. Only the point. All right, 82. Let f be the continuous function such that the integral from 0 to 17 of f of x is 8, and the integral from 17 to 20 of f of x is -3, and the integral from 13 to 20 is 7. What's the value of the integral from 0 to 13 of f of x dx? Okay, so you just got to play around and be, clever with your integral setup. So if you want to find the integral from 0 to 13 of f of x dx, all you really have to do is you would want to add these up, then you'll get the integral from 0 to 20, and then subtract this 13 to 20. So this will be equal to the integral from 0 to 17 of f of x dx. So that's the integral from 17 to 20 of f of x dx, because that'll give you the entire integral from 0 to 20. But then you're going to subtract the part from 13 to 20 because you only want from 0 to 13. So minus the integral from 13 to 20. of f of x dx. So we just go from here. So from the integral from 0 to 17 is 8. So this whole thing becomes 8. Then we go from 17 to 20 is -3. That becomes -3. And from 13 to 20 is 7. So 8 minus 3 minus 7. So 5 minus 7, you'll just get -2. And the answer will be A. All right, 83. Let f be the function defined here. So we have a piecewise function where k cubed plus x is the first piece for x is less than 3, and 16 over k squared minus x is the rest of the function for x is greater than or equal to 3. So for what value of k, if any, is f continuous? Okay. So we want to basically find we basically want to make it so this part of the graph connects with this part. So we want to set this equal to that. That's the first key to recognize. Now, remember, this applies to the left of 3, and this applies for 3 and greater. So the key is to connect it at x equals 3. So we're going to plug 3 into here. And we'll get k cubed plus 3 equals 16 over k squared minus 3. So we want to solve this equation for k. So doing some algebra, we're going to multiply both sides by this. We'll get k cubed plus 3 times k squared minus 3 is equal to 16. Multiplying this out, distributing, we'll get k to the 5th minus 3k cubed plus 3k squared minus 9 equals 16. Take away the 16 and you'll get minus 25 for that. K to the 5th minus 3k cubed plus 3k squared minus 25 equals 0. So we want to solve this equation. We don't expect you to know this off the top of your head. So let's use some technology and look for the zeros of this. So let's go. Hopefully I don't mess up. This is the stressful part for me for whatever reason. So minus 3x cubed plus 3x squared minus 25. Whoops. Crazy. So let's look at that 0. Let's see where that 0 is. Oh. The 0 is about 2.08. So that's going to be our solution, 2.08. And so then our answer will be A. All right, that wasn't so bad. All right, in problem 87, we have that at time t for t between 0 and 2, the velocity of a particle moves along the x-axis given by this equation. V of t equals t times the sine of t cubed. And we're going to let t be equal to b. And that'll be the time at which the particle changes direction from moving left to right. What is the total distance traveled by the particle during the interval from 0 to b? Okay, so this is going to be interesting. So we want to first analyze this graph. We want to first graph this and see where the values of the graph change from being negative to being positive. Typically, if it doesn't specify, when left, will be negative values. and right will be positive values of velocity. We want to see where it goes from a negative value to positive values. And then we have to basically integrate up to b. But the thing is we have to account for the fact that you're going to have a negative area. So let me show you what I mean. So let's first graph this and just get a sketch of what we got going on. So we're going to graph this function, x times the sine of x cubed. Wow, whew. Craziness. Zoom in. I only care about quadrant 1 for now. Let's go one more time. Okay, so we can see the graph is going from positive values to negative, and then let's actually analyze those zeros. So from, say it's positive up until 1.465, then it becomes negative, and then it becomes positive again over here. So let me let's find the other zero. Let's find both those zeros. So we have another one about 1.845. Okay, so let's draw a sketch of this so we can really get a sense of what's going on. That graph is pretty crazy. Okay, so it's doing this sort of thing. It's going down, going up. So this point is about 1.4659, it looks like. And at this point, that point is about 1.845. So we want to find the integral. Okay, so let's first talk about how it's moving from left to right. Remember on this region, you know, the integral or the function is negative. And then after this, it becomes positive. And it becomes positive over here too. So it changes direction from left to right at 1.845. So let b be the time at which a particle changes direction from left to right. This point is where it changes from right to left. But we care about this. So this is our b. So our b is going to be about 1.845. So to find the total distance traveled by the particle, we have to integrate the absolute value of velocity, because this negative integral will cancel out with positive values, and you could potentially get a total distance of 0 if the negatives and positives are equal. So we have to account for this. So either you can do one of two things. Either you could break it up so that you integrate from 0 to 1.4659 d of t dt, and then you could add that to the negative value, because this will be negative, so you add this to negative, because you want to make it positive. So you negative 1 times the integral from 1.4659 to 1.845. You could either do that. That way you'll get, this will be a positive, and then this will be a negative times a negative, so this will be a positive. Then you'll get a total positive quantity. Or you could basically integrate the absolute value of velocity. And in this case, will be from 0, you can go all the way from 0 to 1.845. This will be easier in your calculator, but if you're not, maybe your functions don't work well or something, and your calculator's hard to, to program, you just add them. But anyways, let's go ahead and let's compute this. We go to our calculus screen, numerical integral. We're gonna go from 0 to 1.845, and we're gonna put this in absolute value symbols. So this is where this book, to get that, you're gonna press this, this dictionary encyclopedia book thing. Press that and you'll have all sorts of symbols. And then here I'm gonna enter my function. So x times sine of x cubed. And hopefully I didn't mess up with the syntax. Let me double check, it should be all right. And I got 1.011. All right, and that's correct. Our answer will be C. All right, in problem 88, we have a function f by this, and we want to find how many values of x in the open interval from 0 to 1.565 is the instantaneous rate of change of f equal to the average rate of change of f in the closed interval, 0 to 1.5. Okay, so please just recognize what they're looking for. So when we say instant rate of change, talking about the derivative f prime of x, when is that going to be equal to the average rate of change, which is going to be basically like a slope on this interval. This will be basically like f of b minus f of a over b minus a, just your standard slope. So f of b minus f of a, just the general format you'll see first. So then we just calculate what these are in this case. So f prime of x for this would be 4 or x cubed minus 2x squared plus x minus 1/2. F of b minus f of, so f of 1.565 minus f of 0 over 0 minus, over 1.565 minus 0. 1.5 0 2. So let me punch it in my calculator. We get about negative 0.39205. Okay, so then we want to see then when is this function equal to these values. So we just have to graph this and see at what point it equals this, if any. And one way to do that is just basically make two graphs. Make one graph equal to just a horizontal line, and the other graph equal to that. So let's bust that out calculator. All right, so let me see. Minus 2x squared plus x minus 0.5 adjustment. All right, so let's okay, so now it's one of our graphs, and let's graph another line. We're gonna graph to make it easier for us, just to graph this horizontal line. So our other graph will just be equal to negative 0.39205. Okay, let's zoom in on that. It looks like it's gonna be 3. Yeah, we have 1, 2, 3. One more time. So yeah, so we can see there's 1, 2, 3 points of intersection on our graph. We don't have to actually find the coordinates. We just need to find how many there are. So the answer will simply be